Hi, my name is Todd Reagan. I will be talking today about the Smart Recycle Kit. I also have Varun Burmundi joining me a little bit later to be able to go into some more detail on some other pieces. We also like to thank other contributors to the Smart Recycle Kit. We like to thank John Hill and Revanth Anarati, key components that have worked with us over this project and really would not have been able to do it without them. Today we'll be going into an introduction, sort of an overview of the Smart Recycle Kit. We'll be giving you an actual demonstration of this Recycle Kit and how it works. And then we'll also go into some more details of the solution architecture. And Varun will also be going into some of the actual technical details and giving you an idea of how we actually created the machine learning model that is actually being utilized inside the Smart Recycle Kit. So a little bit of background. So the four of us have been working on this in our spare time over the last 3 years. And we each came in with a little different desire or expectation. I was really excited to see if it would be a way to really help me make that decision of whether I should use how to best use that blue bin that my wife kept telling me is under there. I'm not real good traditionally about what to put in the recycling. So I was hoping that maybe I'd get a better idea through technology on how best leverage that. So to go through that, I started there, but after overworking through that time, I realized there were much bigger issues. And we really needed to step up and be better stewards of the earth and what we've been given here. So two of these issues that are really key in this are climate change and sustainability. We must all work together on these issues, and we're now seeing even consumers make choices on whether they'll buy certain products based on whether the company CEO actually is vocal about the social issues that the consumer cares about. Since recycling is one of those top 5 things that we can really help change, the climate and sustainability, we all must figure out how we can best do our part. The EPA estimates 75% of the waste is recyclable, yet only today we are only recycling around 34%. And even with that 34%, still 25% of it has contamination. So even when we're trying to do a good job, we're doing a poor job. So we really must be able to see how can we do better. And that's really where the Smart Recycle Kit comes in. It's a really small, simple, compact device that we've been able to build, and hopefully we can show you how you can improve the amount of waste that you can recycle, and also how do we all take a more active part in environmental sustainability. So with that, I want to go in and actually show you a demonstration of the Smart Recycle Kit and see what it looks like in action. Before I jump into the actual demo, I want to give you a little bit of what you're going to be seeing. So this is a picture here of what the actual Smart Recycle Kit looks like. It's a small Raspberry Pi device with a little array of LCD screens on top and an external camera. So that's what you're seeing here is just a ribbon cable and everything actually, and you've got that question mark. So that question mark means that it's ready. It's waiting for input. So that's that piece there. Then there's a little joystick. And so that joystick is what we actually press to actually get the process started. So once we decide we put an object in front of the camera, we actually click that joystick, then we're going to get one of a couple items, results. In this particular case here, we're seeing an R that you can see on there. That stands for recycle. We've got that in blue. Choose that blue bin. Then another option would be we need to put it in the landfill. And in this case, there's a red L saying that that should go into, that's where we should place that item. And the other option is a green C, which would be as a compostable item. So these are the 3 options. And based on the actual model, the results of the model itself, we will actually, then we can make an actual decision based on the results that we get back. So with that, I'm going to sort of walk us through. We're going to see an actual demonstration of the device in action. The thing is, you'll see me go in and press that joystick as we described. It'll put one of those letters on the screen. Then you're going to see in the upper left-hand corner, you're actually going to see an image come in. That's actually some of the message that's actually output from an IoT device standpoint from the Raspberry Pi that's sent back into AWS. And Varun will get into more of that, the details of how that's actually communicating and things in just a minute. But just so you know, we're sending a message back to the IoT AWS IoT service so that we can say it was recyclable and what the actual percentage of confidence it was. We're also going to save that item into S3, and that's the top message that you will see, is actually where it actually saved that item. So we'll sort it into recyclable, landfill, or compost, just to make it easier for what Varun will talk about later about the machine learning model. So with that, let's sort of look at what we actually see for the video. What you'll see here is I've actually placed a brown napkin and I've clicked the joystick. And you notice that that has been detected as being compost. And you see here the confidence score and things. I'm going to go through a couple of items here. I went through a Dr. Pepper can. So it was just one of those scenarios that we've gone through, and we're going to show you how this will actually go through, detect, and then running back through that model, it gives us that result to be able to make a much easier decision. One of the wonderful things we've learned over the years, the water bottle is one of the, from a machine learning model, it's one of the very easy, and you'll see a very high confidence score here, over 99%. A little hamburger wrapper in this case, so we'll go through and it'll be a compostable item. And so one of these, you're seeing, it's one of the items it struggles with, because what do we actually do? Is it dirty or others? We have a lower confidence score. Here we've got plastic wrapper. It could be a candy bar. In this case, it was a nut bar that we had. High confidence. It has a good training data set to be able to make that decision. Again, similar to the water bottle. The Coke bottle here is really high, over 99%, and it'd be recyclable. Our last item that we're showing here is a bag of chips that will go into the landfill with a high confidence of over 90% itself. So based on that, you can see how we actually go through and actually make those decisions itself. Varun's going to get into more details here. Varun, let everybody know how did we go through this and actually achieve these items?
Thank you, Todd. Thank you, Todd, for walking us through the demo. Hello, everyone. My name is Varun Bhamidimari. I'm one of the other contributors on this project. As Todd was saying, we've been on this project for over almost 3 years now. We presented our last two reinvents, and this happens to be a more simplified version that we have built so that we give the ability for anybody at home to actually build this out. So what I'll be covering in the next few minutes is to walk you through the overall solution architecture, as well as how to actually build the machine learning model that gets deployed on the Raspberry Pi, which does the actual detection of the actual device. So let me walk you through that. So we'll do the solution architecture. What you're seeing here is the high-level architecture. There's three main services that are involved in this, which is the AWS IoT Greengrass. AWS IoT Greengrass is a service that allows you to extend the AWS functionality over to an edge device, and that allows you to take actions on the device without having to go back to the cloud for everything. It actually reduces the traffic that goes back to the cloud. A few things that to call out is you still have the ability to do a lot of the management aspects of the device, as well as the analytics that you want to do, that you can still do in the cloud, even though most of the logic will be running on the device. The second service that's important here is the Amazon SageMaker. Amazon SageMaker is a fully managed AWS service that allows you to build, train, and deploy machine learning models, which can be used both by developers and data scientists. We'll be covering a little bit of that in the upcoming slides. The third piece is the AWS Lambda. Lambda, for those who are not aware, it provides you the ability to run code without having to run and manage servers. With the Greengrass and Lambda integration, customers have the ability to push the code directly to the edge device and run the code in a container within the device. So the architecture that you see here, I'll walk you through. The first step involves actually building the machine learning model, and we'll be using the Amazon SageMaker service for that and push the model output to a S3 location. The second is the AWS IoT IoT Greengrass connection. So what you do is you register your device with AWS IoT, and then you push the Lambda function to the device that's actually doing the inference at the edge. And then the Lambda function itself does the download of the model that was built using Amazon SageMaker, and then once the inference happens, the inference results are sent back to the AWS IoT service for you to do kind of long-term analytics and some of the management things that we talked about before. So very simplistic architecture, 3 basic services that are involved with this. So let me walk you through how to build this machine learning model, and that's the as I mentioned, the first step. When we will be publishing most of this information, you would have a starting model to begin with, in case you don't want to kind of build a model yourself. But then we'll also be providing instruction to actually enhance the model, and that's what I'll be walking you through. So building a machine learning model, there's a few basic steps, starting off with preparing the data. What you're seeing is a slide, a book walking you through that, preparing the data, training the data, deploying that data to an endpoint for you to actually test it out, and then finally taking the model and then deploying it to the edge device, which in this case is a Raspberry Pi. So let me show you a quick demo and the recording of how to build this model. So what you're seeing here is the recording of walking you through how to build this model. This is a screenshot. This is actually a video recording of the Amazon SageMaker IPython notebook. So there's a notebook service that comes with SageMaker that allows you to run the IPython notebooks. We will be giving this notebook as a part of the deployment. The steps involved, as it shows, is the prerequisites, which just talks about the buckets that are involved, setting up the session, and then the S3 bucket where the data will be copied to in order for the SageMaker to run the training job. So let's go to the next step, which is preparing the data. This is where we download the data from a location that we have specified. The data already has some sample images for compost, landfill, and recycle. So we'll be using the data set to run our training job. This step just downloads the data and copies it to the S3 bucket. The next step is the training piece. This is where we actually use the SageMaker training job to run the MXNet classification model. Pretty straightforward. We specify that we actually want to do the classification MXNet. We specify the type of the instance we want to use for training, as well as some of the other aspects like hyperparameters. The next step is specifying the location of where the training images are specified. And then the final is actually running the training job, which is the fit function. As you see, what the fit function does, it actually prepares the ML instance, downloads the images, and runs the training. Once the training is complete, we move to the deployment piece. This is where we deploy the model to an endpoint for us to actually run the tests, which is just an ic.test. We take the output of that training job and deploy it to an instance that we can invoke and actually run the tests against. So that's the deploy function. And then once the deployment is done, we actually move to the test piece. So this is where we take a sample set of images. In this case, I've taken about 10 images from my test data set, and then I run against that endpoint in order to validate how good the model is. What you're seeing here is it shows you what the predicted value is as well as the actual value, and then it compares the confidence score. So what you're saying is there was an error when the actual was a compost, but what it predicted was a landfill. But if you look at a little bit down, some of the other examples like has a higher confidence score. For example, we had one which was a compost, which was a higher accuracy of 95%. Also on a recycling, we had a confidence score of 100%, which was accurate and was the right prediction. Finally, we run a quick confusion metrics to show you what the actual and the true values and the predictive values. Pretty standard for a classification model. where you try to analyze how good your model is. So in this case, the diagonal values are the ones that show you how good the model is. We want all the values to be in the diagonal. So you see majority of the numbers are on the diagonal. The only variance is in the compost, where it predicted a landfill, but where the actual value was compost. With that, the last section is just telling you the approximate cost of running this. The training job cost is much lower, and then the final one is the endpoint, deletion of the endpoint, and cleaning the cleaning your endpoint. This is an important step because that's the only piece that actually runs after the training is done. So I would recommend you to delete the endpoint if it's not in use. Okay, so that was the training, building the training job. Let me move to the next slide. This one is just giving you a reference to where you can get started with. This is a GitHub repo that will be publishing all our artifacts, including the code, as well as the IPython notebook to build and deploy this machine learning model. So all the instructions will be given to you on this repo link. Finally, I want to thank you for taking time and walking and seeing this demonstration. We sincerely hope this project will help you inspire and join this initiative around recycling. We all believe that we can make a difference here. Take this presentation to your local school and local offices and help build awareness around recycling and trash management. We all can make a difference here. So last but not least, we have please email us. We have a email distro, aws-recycle-arm@amazon.com. We love to hear from you. Thank you again.